In this video, I'd like to go through section 1.1 of our text, not with the purpose of walking you through 1.1, because you can read that yourself, but with the purpose of showing you how your calculator works. So this would be a good calculator introduction, and for this one we're using the TI-NSpire CAS. The version I have here on the screen is the NSpire CX, which is the color version. If yours isn't the color version, your calculator would look pretty much the same, except it wouldn't have color. So let's look at section 1.1 here. So a function is defined. Talks about the domain and range and the independent and dependent variable. But let's cut to the chase down here to quick check 1, where they want you to define a function and evaluate it for certain inputs. For example, f evaluated at -1 and f evaluated at x squared. How would we do that on our NSpire? Well, we'd like to open up a calculator window. You'll notice that A, calculate is highlighted. If it wouldn't be, you could use the arrow buttons to highlight it, and then you click on the enter or input button, and it will open up a calculator screen. So how can we define our function? Everything is going to come from the menu. There's the menu button right there. So menu. We would like the menu for actions, so we'll press the number 1. And we'd like to define a function, which is option 1 again, so we'll press 1 again. We'd like to define the function f of x equals x squared minus 2 times x. Notice you have a keypad down here. It's not a QWERTY keyboard, it's alphabetical, but it's pretty easy to work with. F evaluated at. Notice it gives you the beginning and ending parentheses. So f evaluated at x. Notice we're still inside the parentheses, so we'll click the arrow to get outside. Equals x squared minus 2x. And enter. So our function is defined. Now we'd like to evaluate our function at -1. Now that the function is defined, that makes it easy to work with. F evaluated at -1. Notice there's a difference between the negative number button and the subtraction button. We want the negative number button. F evaluated at -1, enter, is 3. You could have easily done that in your head, but again, we are just practicing with our calculator. Next, we want f evaluated at x squared. F evaluated at x squared, enter. Next, we want f evaluated at t. F evaluated at t, enter. And finally, f evaluated at p minus 1. So f evaluated at p minus 1, enter. So let's see how our calculator did. Let's check our answers. F evaluated at -1 is 3. You got that? F evaluated at x squared. X to the 4th minus 2x squared. We got that. F of t, of course, is t squared minus 2t. F of p minus 1, p squared minus 4p plus 3. And we didn't get that. Now hopefully you'll recognize that a little algebra would clean that up. If we multiply this out or expand it, my guess is we'll get p squared minus 4p plus 3. So how would our calculator do that? Well, again, from the menu button, we'd like to do a little algebra, which is option 3. So we'll press 3 for option 3. Oops. We will press option 3 for algebra, and then option 3 again for expand. And we would like to expand f evaluated at p minus 1, and enter. And notice we do get p squared minus 4p plus 3. It's all worked out. Next, the book talks about the vertical line test, and there's an example of identifying whether or not a graph represents a function. Since the graph is given to you, we don't need our calculator, so we'll skip over that. Let's go to example 2. Graph each function with the graphing utility using the given window. then state the domain and range. We'll skip that part. We'll just see how you can graph with the NSpire. So the first function we'd like to graph is f of x is equal to x squared plus 1. In this window, this notation means we want x to run from -3 to 3 and y to run from -1 to 5. So how do we do that? You'll notice we're on the calculator scratch pad. We'd like to get to the graphing scratch pad. So you would use your buttons here to highlight the graphing icon there and click on it. And you'll notice we have f of 1x equals. It's ready for us. So we'd like to evaluate our function. So our function is x squared plus 1. Enter. And you'll notice it graphs it right away. Now we'd like to change our window, so how can we do that? Well, it's all done from the menu. Again, the menu will be different now because we're in the graphing window. So menu. And it's option 4, window zoom. We'd like to change the window. And we'd like option 1. We'd like to change the window settings ourselves. Option 1. X min. Well, we'd like it to be -3. Use the arrow button to move down. X max. We'd like that to be 3. X scale. We can leave that at auto, or if you'd like each tick mark to be 1, you can change that to 1. How about we do that? How low should Y go? Well, we'd like Y to go at -1 up to 5. And again, you could leave that auto, or if you'd like each tick mark to be 1, you could change that to 1. And enter. So now we get a different look at the graph. Well, let's see how we did. There's the picture the book has. There's our picture. You'll notice a little something different about it. The graph in the book seems a little bit more stretched. One of the things you'll notice about your calculator, notice that one tick mark horizontally looks a little bigger than one tick mark vertically. That's just because this is not necessarily a square window. If you would like each tick mark to look the same in each direction, we can make that change. That's through the menu again. Menu. And option 4. Window zoom. Okay. And let's use the arrow buttons to move down. We would like option B, zoom square. Notice there that that changes the graph, where that each tick mark is the same in both X and Y directions. So it looks a little bit more like this graph. If you don't like the aesthetics of that graph, you can change it back. Menu, window zoom, so option 4. And you can go back to your window settings and change it -3 to 3, X scale 1, Y from -1 to 5, and each tick mark is 1. And enter. Okay. So it's just a matter of aesthetics. Okay, let's look at the second function. G of t is square root of the quantity 4 minus t squared in a different window. Okay. So we would like to graph a different function. Now I don't want to graph more than one function at a time. Sometimes I might want to, but in this case I don't. So I'd like to go back to f of 1 equals. So to do that, we will go through the menu again. Menu. And option number 3, graph entry, edit. We're going to change what we're graphing. And we'd like to edit the function. So 1. So notice f of 2 is there. Okay. If I use my arrow buttons, I could go back to f of 1. And then I can just delete and start again. So I would like to graph. Notice it says f1 of x. It likes x to be the input. So even though here it's asking us to graph g of t, all the functions on your calculator are called f1, f2, so they're always called f. And we use x for our input. Don't let that bother you. We'd like the square root of the quantity 4 minus t squared. So for us, that would be the square root of the quantity 4 minus x squared. So the square root button there, you'll notice, is above x squared, so we need the control. So the square root, and notice it wants you to fill it in, 4 minus x squared, and enter. And it graphs it. Now we didn't get a chance to change our window, so let's do that. From the menu screen, option 4, window zoom, option 1, window settings, -3 to 3, that's the same, so we'll use the arrows to move down. The Y window from -1 to 3 this time, so we'll change that to a 3. And then click on OK. And there's the graph. Let's see how well we did. And there it is. Finally, let's do the last one. H of u is 1 over u minus 1 squared. Again, I don't want to graph all of these functions on the same screen, so everything from the menu, graph entry, edit, change the function. Again, I don't want another function there, so I will use the arrows to scroll back up to F1, delete it, and start again. 1 divided by, now you have to be careful here, u minus 1 will have to be x minus 1, and that's all in the denominator, so you'll need parentheses. X minus 1. Enter. Now that's not the window we wanted, so let's change it. From the menu, window zoom, option 4, 1 window settings. Now here we'd like to go from -3 to 5, okay. Use the arrow buttons to move down, and from -4 to 4. And okay. So again, let's see how well we did. Now, you'll notice in the book it sticks the vertical asymptote in. Our graph does not do that because technically the asymptote is not part of the graph. The book just puts it in there to show you. So again, did a nice job. Okay, let's look at example 3. So a stone is thrown vertically upward from the ground, and the height is given by a function f of t is 30t minus 5t squared. Find the domain and range as they apply this particular problem. So let's graph this and see what it looks like. Again, I don't want multiple things on my graph here. And I'd also like to start back from scratch with my window. So let's do that. Menu, 4, option 4, window zoom. And let's go back to option 5, standard. Okay, that's the standard viewing window. So we can start over. Let's enter our function. Menu, graph entry, edit, option 3. Oops. I must have pressed the wrong thing, so let's go back and try that again. Graph entry, edit, option 1. There we go. Use the arrows to move up. Let's get rid of our old function. And our new function, 30t minus 5t squared. Now remember, our calculator uses a function of x, so we will use 30x minus 5x squared. And enter. So we have our graph there. Notice we're missing a piece of it. And notice it looks like we have more than we need. Now this is supposed to model throwing a stone upward at time equals 0, it starts. So we really don't need this portion of the graph back here. So let's change our window. From the menu again, window, option 4, Window settings. So let's make our x minimum 0, because that would be time equals 0. We can leave the x max at 10. Change our y minimum to 0, because presumably the stone is not going to hit the earth and tunnel through it. And we'll leave our max what it is and press OK. So now we have a view here. Notice the stone goes up. We don't know how high it gets though. And then it comes down. So to see how high it gets, we need to change our window. So menu, window zoom. Oops, let's try that again. Window zoom, there we go. Window settings. Let's see, how about we go to a max of, say, 50. Let's see if that'll work. This is just trial and error. Oh, it does peak out. So you'll notice the rock goes up, comes down, and hits the ground. Okay. If you want more control over these tick marks, remember in the window, you can change the scales to 1. So, looking at the domain and range, well, it's clear that the domain starts at 0, and then when does the rock hit the ground? Well, if each tick is 1, it looks like it's 1, 2, 3, 4, 5, 6, so close to 6. How high does it get? Well, we don't know. 50 is at the top, so it's a little less than 50. So how could we figure these out? Well, to find out when the rock hits the ground again, that would be when the height is 0. So we can solve this function to find out when it equals 0. So let's go back to our calculator. By the way, you could also press the calculator button to switch back and forth. So we'd like to find out when our function f1 is equal to 0. So how can we do that? Again, everything's done from the menu. This time we'd like to do a little algebra, so option 3. And we would like to solve an equation, so option 1. What would we like to solve? Well, we'd like to solve the function f1 evaluated at x. Oops, I've got 2 x's there. Use the arrow to get out of the input, and we'd like to find out when that's equal to 0. And we'd like to solve the variable for the variable x. So, comma x. And enter. So the function is 0 when the input is 0 and the input is 6. So that makes sense at 0 because you haven't thrown it yet. And at 6 it hits the ground like we suspected. So let's click this toggle switch to go back. So the graph does indeed go from 0 to 6. Now how high does it go? So menu, analyze the graph, maximum. So it asks for a lower bound. So as you press these arrow buttons, it moves the lower bound. You just need to be the left of the peak, and then press enter. Upper bound, use the arrows. And again, you just need to be to the right of the peak. And then press enter. And it gives you the maximum there, the point 345. So the maximum height is 45. So the range would go from 0 up to 45. Let's see how well we did. So it looks like the domain is 0 to 6, which we figured out, and the range is 0 to 45, which we figured out. Okay. So the next problem. What are the domain and range of this function? Okay. Well, let's start over. Menu, graph entry, edit. So option 3, we're going to change our function, option 1. And again, use the arrows to move up. We're just going to wipe out F1 there. So let's enter this in. X squared plus 1 use the arrow to go outside of the parentheses, to the -1 power. So let's use our exponent button. Notice it puts us in the exponent, and we can put to the -1 power. Now notice our graph is a mess down here. We don't see anything because we didn't change the window. So let's go back to the standard window. So option 4, menu, option 4. Let's do option 5, standard, to get started. So this graph looks like it's pretty low. It pops up, has a bump, and then it comes back down again. Let's get a better look. Let's go to our menu, option 4, oops, window zoom, option 1. I don't think we need to go as high as 6 and as low as negative 6. So how about we just do -1 and 1. And enter. So there is our graph. Looks a little busy here. We have some extra stuff here, and then we can move out of the way. So it looks like this graph rises. It seems to peak here at 1 and then come back down again. So it looks like it has a horizontal asymptote. How can we? So the domain looks to be all real numbers as you scroll from left to right. How about the range? How can we find out how high this is? Well, let's go back to our menu. Menu, analyze graph, maximum, lower bound. Well, again, we just need to be to the left of the peak. Okay, we're to the left of the peak. And now we need to go to the right of the peak. So keep clicking the right arrow. And it looks like we made it, so enter. So you'll notice it says the maximum is -1.09 times 10 to the -8, which for all practical purposes is 0. And the maximum height there is 1. So the domain is all real numbers, and the range goes from 0 up to 1. Notice 1 is included. 0 would not be because of the horizontal asymptote that seems to be there. And did we get that one right? Yes. Range 0 to 1, including 1, but not including 0. Okay, let's look at composition of functions. Again, it defines them, and let's look at example 4. So define some functions and then simplify the following expressions. Okay, so this, we want to go back to the calculator scratch pad. So again, you can try to click on that, or you can just click on the toggle switch, which is easier. We're back here. Now this is getting a little busy and full. If you'd like to clear the screen, you can go to the menu, actions, so number 1. And number 5, clear the history. That will clear the screen. So notice that clears your screen, but it does not clear your variables. Remember, we defined f before. It's still there. If you would also like to clear your variables, that's also from menu, and it's also from actions, but it's option 4, clear A to Z. Would you like to clear the variables? Enter for OK. Now you'll notice if we type in f of x, we won't get anything because the variable's been cleared. Okay, so let's clear the screen again. Actions, clear history. So let's start over. We'd like f of x to be 3x squared minus x and g of x to be 1 over x. So let's define that from the menu. Actions, define is option 1. Define f evaluated at x. Use the arrow to get out of the input parentheses. Equals 3x squared minus x. Enter. And we'll define another function through the menu. Actions, option 1. Define option 1. G evaluated at x. Get out of the input parentheses is equal to 1 divided by and enter. Okay, so let's see. We'd like to evaluate f at 5p plus 1. So now that the functions are defined, we can do that. F evaluated at 5p plus 1. Enter. Now remember, that's not multiplied out. If you'd like to, we could expand that, and this gives me an opportunity to show you a little trick. So we would like to expand that, so menu, that's from the algebra menu, so option 3. Expand, option 3 again. Now we could retype this, but a trick to retyping, if you use the arrow button to go highlight something and press enter, it will pop it right in. So now if we expand that, there's the expanded version. Next we'd like to do g evaluated at 1 over x. We can do that. 1 divided by x. Enter. So we have x, we have a little warning symbol here. That's warning you that there could be domain issues. So for example, if x is 0, this would not work. Now we want to do function composition. F composed with g of x, we can do that. F composed with g of x. Notice the parentheses are closed for you. And g evaluated at f of x. G evaluated at f of x. So, how did we do? Let's check our answers. F evaluated at 5p plus 1, 75p squared minus 25p plus 2. Let's scroll back up here. And that's what we got. Notice we did get the same thing for f composed with g. Our answer looks a little different. Notice the answer in the book has a common denominator. Well, we can do that. Let's move down to the entry line. That's an algebra feature, so menu, option 3, algebra. And let's see, solve, factor, span zeros, complete the square. Looks like maybe it's fraction tools. Let's try that, number 9. Common denominator, there it is, option 4. So we want the common denominator for f evaluated g of x. Now again, you could type that, or you could use the arrows to highlight it and press enter. And it types it in for you. 3 minus x over x squared, exactly. Now for g evaluated at f of x, again, we didn't quite get the same answer. We got 1 over x times the quantity 3x minus 1, which you can tell is the same thing. But let's play around with some algebra here and see how we can get these to be the same. Let's try the common denominator again. Menu, algebra, fraction tools, option 9. Let's try common denominator again. Common denominator of, this time it's of g composed with x, with f, I'm sorry. And that gave us our answer. Okay. Let's see, what's our example working with composite functions? These don't use our calculator, so let's move down here to secant lines and the difference quotient, which you could read about. Gives you the definition of the difference quotient and a secant line. A secant line is just a line connecting 2 points that are on a curve. And the slope of that line is given by the difference quotient. So let's see how we could do that. Let's move down to the example. Simplify the difference quotient for f of x equals 3x squared minus x. Now luckily that's our function. Just to remind you, that's the same function we just defined in a previous example. F of x, enter. So we don't need to define a new function. So let's calculate this. The numerator is f evaluated at x plus h minus f of x. So we need parentheses. F evaluated at x plus h. Click to the right to get out of the parentheses, minus f of x. So notice the whole numerator is in parentheses. Use the arrows to get out of the parentheses, divided by h, and enter. Now again, you get a warning symbol because it has to do with the domain. You know, what if h is 0? Okay, let's see how we did. The book says the answer is 6x plus 6h minus 1, and that's not what we got, but the book has a typo in it. You'll notice, looking at this fraction here, if you cancel the h's, you get 6x plus 3h minus 1, which is what we got. They just turned that 3 into a 6 magically, so that's just a typo. So we got it. Let's look at part B. Let's do the other version of the difference quotient for f of x is x cubed. Okay, so let's redefine f from the menu. Actions, define. We are redefining f of x to be, use the arrow to get out of the input, parentheses, x cubed. Oops, I forgot my equal sign, so I'll move back using the arrows and put it in. There we go. So now we'd like to compute this. We have a numerator that's made up of multiple things, so we need parentheses. F evaluated at x. Get out of the input parentheses. Minus f evaluated at a. The fact that this gives you the opening and closing parentheses is both good and bad because you have to remember to get out of the parentheses. Divided by, the denominator is also a grouping, so x minus a. And enter. And again, let's see how we did. X squared plus ax plus a squared. Right on the nose. So that is a quick walk through section 3.1 with the sole purpose of getting used to your calculator. So hopefully this was helpful, and hopefully you can see the power of your calculator to help you do some algebra and some graphing.